Hi everyone, today we will see how we can combine analog input and analog output together, and we can get some worthy project. Actually we can do some worthy projects, worthy application, let's say in Arduino, right? So what we are going to do is, let's say you are going to take an analog input and you are going to pass that particular input to another analog output. Let's say we are going to dim an LED, like we are going to increase the illumination of an LED or the power of an LED and also we should be able to decrease that illumination or power of the LED as well. But to do that we are going to use an input, analog input, and we are going to immediately pass that particular analog input to that LED output, so that according to the analog input that the LED output may change. So to take that analog input, we can use a variable resistor that can be a rotatable one, like you can think it as a fine tuning analog switch or button, something you see to control the radio volumes or something like that. So you can think like that. Or it can be an LDR. So from the LDR's input we can change the LED's output, because when the light is very much light is falling on the LDR, very higher power of LED is there. So you can see that when the LED power is high, we can see that LDR's having a high input, analog input. So it may not be the very much power, it depends on the analog input. Sometimes the LDR may have high analog input when there is low power, low light. So that depends on the LDR's nature, I don't remember. So if that analog input from the LDR is high, that LED will be high in power, in illumination. If that is low, then LED will be low. So it will indicate that, right? Indicate the condition or value the LED will do. Or you can use it as a variable resistor or something like that. So how to use an LDR as an analog input, how to use a variable resistor as an analog input, things like that we will study further in future upcoming videos. But for the moment you can think we are getting a particular analog input and we are going to give that particular analog output to an LED or something, so that from that output of the LED or from that particular output we can guess what is the analog input, or it's a maximum, or it's a very lowest, or in the middle, things like that. So anything, right, you can do. So actually we are going to combine the analog input and output. Okay, so what I will do is I will first write the code, that means setup and loop. So I can do it very fast, so probably since you guys know it very well now. Void setup is here, void loop is here. Okay, so that's it. Then what I will do is I will I need to take an analog input and analog output, right? So first we will write some analog input. So first we will use, let's say we are going to use A0 for the input purpose and A1 for the output purpose. So you know what I have to do, right? So pin mode. So we are going to say which pin is input, which pin is output. So A0, it's not 0, A0 as input. Okay, so this is must, you should do this. And also we have to say A0, A1 we are going to use output. So one time running of this coding is enough, because if you say it one time, Arduino will remember it whenever it is needed. Okay, so that's enough, because we are not going to run this as an output. It is just something we are telling, and remember this, telling the Arduino to, okay, this is this, remember. So one time is enough, so it is in the void setup. Then what I'm going to do is I'm going to take that analog input. Okay, first thing about the input part, right? So the same coding I'm going to write. So to take the analog input, the keyword is analog read. Okay, so the thing we have seen in previous videos, if it is unclear, you can go watch and come back. So when I'm saying analog read, why I'm saying it inside the void loop is this has to continuously happen, right? Because when you are changing the value, whatever the output has to change. So you are increasing the value, decreasing the value, you can do anything. So the coding has to be running forever. Then only the change in the value can be interpreted or identified. If it runs only one time, it runs one time and the running is stopping. So when you change it further, it cannot change the output, because it has finished running, right? So you have to keep it running. So that is why we are writing it inside the void loop. So I'm reading the analog read. So those things you already know, that void loop, void setup, why I'm writing it here and there. If you don't understand, go watch my previous videos and come back. Okay, so analog read, we have to pass that a0, that's enough. Okay, so I'm reading the a0 value. So then you also already know we have to assign it to a particular variable. So let me assign it to the variable called x. So that has to be an integer variable, right? So what I will do is I will declare the integer variable on top after assigning the value. So I will say int x. Okay, once I define that, I'm using the x here. Okay, so now the analog read value, whatever the value you are changing, is always keep stored in x. Okay, in the variable name of x, and even it is changing, the x value is changing, so you don't need to worry. Whatever that value you are changing will be will be stored in x. So when you keep changing analog input value, the x value will be changed, obviously, right? So this is the analog read part, right? In the line number 3 and 9, this is how we read analog values. So now the problem is we have to pass that particular analog value as an output, right? So I will write another word, analog. How to give an analog output? You have to write analogWrite. Okay, and then what you have to do is you have to say this pin number and the output value. Okay, so first I will tell the pin number. So for giving the output, we are going to use A1, right? So I will say A1. So you should know analog read, analog write things. Otherwise, go watch my videos and come back previous videos. A1, and you have to pass the value, right? So if you can pass x, would it be successful? That's a problem. Okay. So what is the problem is we from the previous videos we know when we are taking an analog input, that value can be changing from 0 to 1023. Okay, 0 to 1023. That means 1024 units because it starts from 0. I explained you all those things. So, but when you are giving that analog output, you only are capable of giving up to 255. 0 to 255. That means 256 units. So this is, the first one is 1024 units and the second one is output is 256 units. So within that, when you are getting analog inputs from 0 to 5 voltage, okay, or whatever that maximum voltage, or let's say 0 to 5 voltage, we are breaking it into 1024 units. But when we are giving outputs, we have to give the 0 to 5 voltage within the 256 units. Okay, so this 1024 input should be divided into 256 units. Okay, so output units. So we can think this is out, this is in, right? So we can think how many how many input units can go to one output unit, or also we can think how within one output unit how many input unit we can have. So simply you have to divide 1024 by 256. Then you will know within one output unit how many input units can be included. So within one output unit, 4 input units can be included, because if 1024 divided by 256 is 4. So with one output unit will contain 4 input where it is go input units. Okay, 1024. So I hope you understand that this is not that hard, right? So only thing about this conversion, right? So 1024 in is equal to 256 out. So 1 out will be how much? 4 ins, right? 4 is to 1 is the ratio, obvious, right? So if I take 1023 as an input, the value I have to give an output is what? 255. You understand? The thing is, we cannot even give to 656 because we start from 0. Okay, so there must be a way to convert this 0 to 1024 into 0 to 1025. So somehow we have to divide it into 4, but also the -1 scenario is also there because it starts from 0. Everything is. So how we have to do is, I am going to do a small mathematical operation. What I will do is, I will have a few more variables. So what I will do is, first I am taking that analog input. Okay, let's say this is 1023 at the beginning. And what I will do is I will add one more value to the particular input. Okay, so if it is, let's assume this is 1023, then I have to change it to 255. Okay, so what I will do is I will say another integer variable as y. Okay, I will declare this variables later, y, and what I will do is y is I will add +1 to x. And okay, so when I add +1 to x, what happens? Let's say x is 1023. You are getting full analog input. The output you have to give is 255, right? Full analog output. So first what I will do is to make a equation that is suitable for all these converting values. To convert all the values, we will first take 1023 and 255. How we can convert 1024 into 255? First what I will do is I will add 1 to the x value, the analog read value. So 1023 is, let's say 1023 is the analog read value, that is x. Then now I am adding +1 to the x, that means 1024. Now what is the value of y? 1024. Then what I will do is I will divide the particular value by 4. So this thing sucks. Okay, fine. By 4. Now what is that? 1024 is divided by 4. So if you divide 1024 by 4, what is the value you will get? 256. Yes or no? Yes. So now this part is done. This part is done, but I have to bring it to 255. So what you will do is you have to deduct 1. That means you have to subtract 1 from the total value. So this is 256 because 1023 is x plus 1 is 1024 divided by 4 is 256. 256. I have to make the 256 into 255. So what you have to do is you have to deduct 1, or you have to subtract 1 from the total. So minus 1. I'm sorry guys. Minus 1. So then the whole equation is done. You can take any value and you will find. Let's say the half of this 1024 unit is 512, right? So since the 512 units, if you have to give 512 units, the value will be 511 because it starts from 0. So 511 is the half value, right? But when it comes to 255 setup, then 256 is the full value. 128 is the half value. Since it starts from 0, 127 will be the half value. Okay, I hope you can understand this. Because we have to divide by 2 the total units, we have to divide by 2, and we have to decrease by 1. Okay, that is how we got this also. Every value we have to decrease by 1 because it starts from 0. So 127 is the half value of this 255 analog value. Okay, that is respectable to 511. So if you take the 511 is the x value, that means a0 value, it has to become 127, right? Obviously. So you will add 1, that means 512. Then you will divide it by 4. So you will get somehow 128, and then you subtract 1 from that. 127 is there. So this equation will convert this 1023 0 to 1023 values to 0 to 255 values. Or you can say this particular equation will convert 1024 unit scenario into 256 unit scenario. Okay, so if you don't understand the equation, again replace the values and see what happens. Okay, are you getting the correct value or not? That's what you need to know. So now we are capable of giving taking the analog input, and we are capable of giving particular analog output for that exact input, right? Respective exact input, you can give the output. So that is the value of y, right? So we will pass y here. I'm sorry, right here. So we are done. That's all. Okay. So now you can connect an analog input like variable resistor or LDR. So such things we will see in upcoming videos. And also you can connect an LED to A1, and you can see according to the particular analog input, that analog output of the LED is changing, or the power of the LED is changing. So I will delete this part because this is not needed, and I have to declare integer y as well. So integer y I will declare. So I hope this scenario is very clear. If you don't understand this, watch it once again, watch the video, and try to go through the code. Importantly, the code that is in line number 10. that means the conversion. Okay, so now you have a proper full system with an input and output, working output, right? So that's amazing, right? So hope you guys give a try on that, so that I feel worth of doing these videos, and consider subscribing us. So until I meet you in the next video, have a great day ahead. Bye.